This video just talks about how to convert degrees to radians, radians to degrees. I just want to kind of give you a brief background of where radians come from, because a lot of students will come and say, why do we need radians? Why is that so important? So, essentially, in a nutshell, every polygon has a certain amount of degrees it can hold, right? So, like if I had a triangle, let's say I simply just put this is 30, 90, and 60. Okay, right? All the angles inside of a triangle always add to equal 180 because it's a triangle. So all those numbers can be different, but all the angles added together will equal 180. In a rectangle, again, all the angles added together will equal 360, or any quadrilateral or four-sided polygon. And all you do is add 90 degrees to each side, and it tells you how many degrees can be inside of the polygon. And what if I get to 20-sided polygon or a 30-sided polygon, right? That would be kind of ridiculous, right? To draw that and all those shapes. So here's the idea that these Greek mathematicians thought of. If I continue to make a 20-sided polygon, a 30-sided polygon, it's eventually going to look like this shape. What is this shape? A circle. So rather than measuring the angles inside of a polygon, they said, well, let's measure the rotation around a circle. So rather than measuring the angle inside, we measure how far we traveled around the polygon. So when we think of a circle, what's one of the key features of a circle? It's the radius, correct? And we know that the circumference of a circle is 2 pi r. So, right, 2 pi times the radius. But let's say I wanted to cut it in half, right? So wait, actually let's talk about this. The circumference, when I go all the way around the circle, how many degrees is that? This is 360 degrees, correct? So 360 degrees equals 2 pi radians, or the radius, right? But what if I wanted to cut it in half? So divide both sides by 2. That would be 180 equals pi radians. So what we say is, if I divide by pi, 180 divided by pi equals radians. So this is what we need. This is the magic fraction we would need to convert from degrees to radians or radians to degrees. All right, and so this is what that looks like. Okay, so if I'm given 300 degrees, okay, what I do is multiply by pi over 180, like we just discovered, right? So I cross off a 0 because that's just good cross-canceling. I multiply straight across, but we can cross-cancel. 30 and 18, 6 goes into both. 6 goes into 35 times. 6 goes into 18 3 times. So this would be 5 pi over 3 radians. Oh, let me go back for a second. So when we're talking about radians, what we're really saying is how far along the circle am I traveling? So if I go, so 300 degrees would be something like this, right? So that means I traveled all the way around here. What would be that length that I've traveled around? And that would be, in this case, 5 pi over 3 would be the circumference I've traveled around. Okay? So that's how we measure radians. Let's do another example just to make sure you got it. Let's type in 405. Okay, 405. Again, we want to get rid of the degrees and write radians, so we put pi over 180. 5 and 0, that means 5 can go into both here. So 5 can go into 400, let's see, it goes in 48, 81 times. And 5 goes into 18, 3 times, 36 times. All right? Yeah, 36 times. 81 and 36, I believe 9 can go into both of those, right? 9 goes into 81 9 times. 9 goes 36 4 times. So my final answer would be 9 pi over 4 in this case. All right? So that's how you convert from degrees to radians. Obviously, you can go backwards if I wanted to. And I can do from radians to degrees. So let's say I'm given 7 pi over 2 radians. And I want to change it to degrees. All I do is flip the fraction. I do 180 over pi. What happens is pi gets canceled. And then 2 can go into 180 90 times. Then we just do 90 times 7, which is 630 degrees. All right, let's do another example, just to make sure we got it here. Let's do 11 pi over 6. All right, let's go ahead and, again, we want to change it to degrees, so we got to cancel out pi. So we'll put pi on the bottom. Pi cancels out. 6 goes into 180 30 times. And obviously the 6 goes to 1. So 11 times 30 would be 330 degrees. All right, so that is how we convert from degrees to radians or radians to degrees. We use that magic fraction, which we derive from here. Again, using the circumference, that's how we get that magic 180 over pi or pi over 180.